Okay, guys, so today we're going to take notes on continental drift so that you can get started working on your plate tectonic book. So, first off, we have to talk about what is the difference in theory versus law in science. So, what do you think that term means? If I talk about scientific theory composed to scientific law, and this has to go back to the scientific method that you should have learned back in probably first, second grade. Well, in science, laws are simple facts. They're pretty much the highest you can ever become to being true in science, and formulas that are basically that apply to universal things and are replicated. So, for example, the Newton's three laws of motion. The second happens to be force equals mass times acceleration. That is a law, meaning that it is a fact in science. While laws rarely change, theories can actually change as new evidence is discovered. So, a theory in science is something that has been proven true again and again. However, it's not officially a law. Like, we don't consider it to be fact. It can change as new evidence appears, as technology grows and changes. So, know that a law is above a scientific theory. So, when we get into what we're about to talk about, I just want to note and I want it to be very clear that I am in no way telling you that you have to believe in anything that we're talking about. You just have to know the information and the content, okay? Because I'll never tell you what you have to believe in. So, when we talk about the plate tectonic theory and continental drift, you have to talk about Alfred Wenger. Now, he's actually German, so that's how you pronounce his name. He lived from 1880 to 1930. He proposed that all the continents were once connected together in this huge landmass called Pangaea, but separated and drifted apart over time. He named that giant landmass, like I said, Pangaea, which means all land. So I know you've heard of Pangaea. The idea that all the land was once together and broke apart came from Alfred Wenger. So, this idea is called the theory of continental drift, and he proposed this in 1955. So, let's go over the theory of continental drift. You are definitely going to need to know that. The theory of continental drift was that he believed that all the land was once one big landmass called Pangaea and then broke apart and has been moving ever since. That is the theory of continental drift. There was no Atlantic Ocean at this point. Pangaea was surrounded by one ocean, and Panthalassa is what they called it. So this landmass broke apart into several different continents about 200 to 250 million years ago. So if you look at this picture, it kind of shows you that Pangaea was starting to break apart, and you'll notice you can almost kind of see the outline of a lot of the continents, but they do look different than from what they are. And from 25 million years ago to the Triassic, 200 million years ago, Jurassic, Cretaceous to present day. So this theory that the plates are breaking apart and moving goes under the continental drift theory. Now, Wenger's idea of continental drift was controversial, meaning that a lot of people actually did not believe this. They wanted proof that the continents had drifted apart and were still doing that and occurring. To prove this idea, Wenger found four major pieces of evidence. So definitely know these four. Shape, meaning that if you look at the actual outline of the continents, they do look like they fit together like puzzle pieces. Fossils was his second piece of evidence. He was finding fossils, the same fossil in different parts of the world. Climate, and last, rocks. So we're going to go over each one of these in detail, and this is definitely going to help you on your plate tectonic book. So let's talk about shape. If you look at the map of the Earth's surface, you will notice that all the edges of the continent look like they fit together. If we kind of go over here and we look at Africa, the Horn of Africa looks like it could just fit right up here into the Gulf and the Atlantic coast of North America and South America. Or if you look at the the east point of South America, looks like it could fit right up here to the west of Africa. So that's what he meant together by shape. The second one was fossils. Fossils of the same species were found on different continents, and the example is the Mesosaura. So the Mesosaura was this reptile that lived on land and fresh water. And if you'll look, it's actually this alligator-looking fossil right here. They found the exact same fossils of the Mesosaura in the southern tip of South America and in the southern tip of Africa. Now you have to keep in mind, these continents are thousands and thousands of miles apart, separated by ocean, and these animals could not survive in salt water. So how did the same fossil get on two separate continents? Not only that, let's look at this fern. This plant, there were fossils found in Australia, Antarctica, India, Madagascar, Africa, and South America. Now we know plants don't move around, and winds are not going to be strong enough to blow the seeds that far of a distance. So how could all these fossils possibly get in all these different locations? Well, what he was trying to say is that maybe all the locations were once together where the animals could and the wind could freely move it across the different continents. So here's just that picture blown up. And you're going to, make a puzzle piece of Pangea putting these fossils together. So how is that possible? If the continents were once connected very close, so the reptiles could move freely from one landmass to the other by swimming or walking. But the way they are today, it is too big for them to swim across. Now, as we said, the tropical plants in Antarctica, how could a tropical plant be in Antarctica? I mean, when you hear the word Antarctica, what do you think of? Freezing cold. But yet this tropical plant was found there, as well as India, Africa, South America. So how is this possible? The continents must have been connected, or at least were very close so the seeds could evenly be separated by wind dispersal. So as you can see, if I'm going this much detail into it, fossils is a very big, important piece of evidence. Again, another picture showing you the fossil evidence. All right, so let's go to the third one, which is climate. Wenger noticed that there is evidence of major climate changes. And the evidence was he did actually notice in sediments that glaciers and different plant fossils existed. Warm weather plants were found in the Arctic, and areas that were normally tropical towards the Arctic. So what must have happened? The example is evidence of glaciers in the tropics. So you're telling me that there were glaciers in a tropical location, but then there were tropical plants in the Arctic? That must mean that the climate had changed, that these glacier scratches can be seen in these warm tropic areas because maybe it was actually cold back then because the continents have moved since where they originally were formed. So here's a picture to show glacier scratches in Africa, South America, India, and Australia. Notice how there's not any on Antarctica, which we consider to be where all the glaciers are now. Again, another picture showing you how he believed it to be, his evidence, and how they are today. And look how they fit together. Again, going back to that shape. All right, and so the last piece of evidence is rocks. Rock type, age, and structure actually match the Appalachian Mountains, which are in the United States. So if you actually take a section of rock from the Appalachian Mountains, he noticed that it exactly matched this chain of mountains in Europe. So how could the exact same structure of mountain ranges be connected? Well, again, it went back to his proof that a long time ago, maybe all the continents were connected, and it was one big mountain range that had since been separated as the continents move around. Okay, so again, the four pieces of evidence are shape, fossils, climate change, rocks. You definitely need to know those four. And those are all the evidence for the continental drift theory. So again, here's some pictures of the mountain ranges and other mountain ranges that match up. So was all this a proof enough? Well, despite all these pieces of evidence that Wenger gave, people still did not believe in the theory of continental drift. The problem was that while Wenger was able to show evidence, he couldn't explain the how and the why the continents had moved. He didn't know because technology hadn't existed yet. So that's where the theory of continental drift ends. Now we're going to get into the plate tectonic theory, a whole separate theory on its own, but includes the continental drift. New information was found. It wasn't until late in the 1960s when Harry Hess, who was a geologist and an oceanographer, was studying the age of the ocean floor, that more evidence came out to support Wenger's theory of continental drift. Hess actually found mountains at the bottom of the ocean, hence what we now call the Mid-Atlantic Ridge. Now, Henry Hess was actually in the Navy, and while he was working on a Navy ship, he would do some of this oceanography on the side by using echolocation and sound waves to go hit to the bottom floor, and that's how he discovered the Mid-Atlantic Ridge. But he still didn't know how they got down there. And he later came up with this theory of seafloor spreading. Seafloor spreading is the process in which new ocean floor is created when two plates move away from each other. This became evidence needed to create the plate tectonic theory. So really, the plate tectonic theory is everything that Wenger said. It is the continental drift theory, that all land was once Pangea, that it has broken apart and moving ever since, with the four pieces of evidence. But seafloor spreading was able to explain the how did it happen? How did the continents move apart? Well, the seafloor is spreading. The plates are moving apart, and as the plates move away from each other, this hot liquid magma that's inside the mantle rises and cools off and becomes new crust, making them expand. So just think about if this was constantly moving, these two continents would be pushing away from each other as the ocean floor expanded and expanded. So that is a plate tectonic theory. Everything that Wenger said, adding in seafloor spreading. So make sure you do note that. So evidence of seafloor spreading is made out of basalt rock on the seafloor. And from 6th grade, you should have learned that basalt is a very dense igneous rock. It's formed from volcanic eruptions, and it is slightly magnetic, and it does form in directions to create these lines. The Earth's core is also magnetic, and it attracts the basalt rock, which helps them to floor along the seafloor. And this actually shows striations, which allow us to see how old different rocks are. As the seafloor continues to spread apart, the older oceanic crust moves away from the Mid-Atlantic Ridge. So if this is the point where new crust is being made, as you're moving farther and farther away from this point, pretend there's arrows here, the crust is getting older and older. The closer the crust is to the Mid-Atlantic Ridge, the younger it is. The farther away, the older. So scientists would argue about seafloor spreading, and the continents must be moving apart. Okay, so now we've explained the how is it happening because of seafloor spreading. Well, let's get into the why. The why is convection currents. Remember that thing called convection from 6th grade? No, probably not. Well, let's just show how important it is again. The Earth is made out of these large, huge plates that have been broken apart. And these plates, which is the lithosphere, is moving on top of convection currents in the mantle. Now, from 6th grade, you should have learned that when things heat up, they rise, and when they cool off, they sink. And when they heat up, they rise, and when they cool off, they sink, creating this circular motion, which is called convection. So as the convection currents are occurring deep within the mantle, these thin plates of crust are moving on top of it. So the Earth, to help them further move apart. So this is why seafloor spreading is happening, because there is convection occurring deep within the mantle, because the magma is heated unevenly. I mean, think about it. Where's the hottest part of the mantle? It's going to be down here right on top of the core. Where the coolest part of the mantle, even though it's still very hot, is going to be up here, farthest away from the core. So this uneven heating of the core of the mantle is what caused the convection currents. So tectonic plates movements are what create all the features that we see on Earth's crust: mountains, ridges, valleys, trenches, islands. And again, we're going to go into all this in great detail as you get farther in your plate tectonic book. Okay, so here are some videos if you wanted to watch them on Seafloor Spreading and Alfred Wenger. But I just want to make sure that you understand the difference between the plate tectonic theory and the continental drift theory. Okay, this should help you answer questions or pages 1 through 5 in your journal. So make sure you took really good C notes. If not, pause, rewind, and go back. Enjoy.